I want everybody to be able to look at them as I am. Does this, whoever went into it, does this look like your question one? All right, so write a function prototype, i.e. don't include a body, a boxy. Hunter, I didn't fix that after you noticed it, of a function that meets the following requirements. The function name is Ummagumma, which if you're a Pink Floyd fan, you'll go, oh, haha. It returns no value at all and accepts a double named D as a parameter. All right, well, what is a prototype? A prototype is a function header, and I did not mean to start idle, not in Python. So what is a prototype? A prototype is a forward definition of a function so that you don't actually have to have the body of the function right there. And the reason prototypes are useful is so that you don't have to declare everything in order, right? We always have an int main, right, somewhere. But what if we wanted to put our function in another file? Or what if we wanted to put our function down underneath, right? Say we had a function called A, for whatever purpose. It's supposed to do something. As is, this would not work. In Java it would. Java is a little bit more generous about the order in which you can put things. Order does not matter in Java. In C++, they matter a great deal. This would be a syntax error. Why? It would go, I have no idea what A is. And so what if, you know, this was supposed to be int x equals A. It needed to take the return value of here, right, return -1. And we would want, when we invoked A, for it to jump down here, process this code, return the value to be stored in X. But the compiler doesn't know what A is. It doesn't know if it needs to pass in any parameters between the parentheses. It doesn't know what its return type is. It knows nothing about it. So we can come up here and add a prototype. And we say, oh, by the way, you're going to, Mr. Compiler, you're going to run across a reference to a function named A. And here's everything you need to know about it. Now, why didn't we just put this body of the code up here like we've done every other time? Because it might be stored in another file. It might be stored in a DLL library. We might not want to put things in the order so that main is down at the bottom of the code. We might want to put the prototypes in a header and put all of our functions in a different file. So that's what a prototype is. A prototype is a function header without a body that is used to let the compiler know what a function returns, what type of function returns, and what type of arguments, parameters it accepts. That's what a prototype is. So write a function prototype, i.e. don't include epoxy, a body, of a function that meets the following requirements. The function name is Ummagumma. Okay, well that makes it easy. I give you a function name. Let's type that, Ummagumma. It returns no value at all. Well, something that returns no value is declared in this language as being void. Man, this is noisy. I'm going to drive the listeners at home crazy, as it drives me crazy. And it accepts a double named D as a parameter. Okay, so here's this parameter list. Double space D. It doesn't have a body, so we just end it with a semicolon. Now what would happen in our code if we had this, but we didn't have that? What if we cut that out and we compiled it? It would compile just fine. But then when the linker ran, it would say unknown or could not find a body for this function. Because that function doesn't exist. We've defined it. We've said it exists, but we never actually provided a body for it. So we'd better go and find another CPP file that had it, or we better add it to our code or something to that effect. All right. Write a function prototype that meets the following requirements. Its function name is add3. It returns a double. It accepts 3 doubles as parameters. I want somebody to tell me what to type. Somebody brave. Shelley's up in the front row. I'm going to make you do it. If you don't know, that's okay. What is our function name? Add 3, okay. And it returns a double. So what do I need to put in front of it? Double. Yeah. And then it accepts 3 doubles as parameters. So double D1, comma, double. I wish you could just type double D1, comma, D2, comma, D3. But double D1, comma, double D2, comma, double D3. And it's a prototype, so we don't include a body, so we put a semicolon there. Pardon me, Simon? Do we need to add public static? If these were methods, yes, but these are just functions. They're not part of a class. So yeah, the question was, did we need to put public there, like we saw when we played with classes? No, because these are not part of a class. In some languages, everything is part of a class. In Java and C#, you can't get away with defining a function that's not part of a class. So, yes, honey?
Can you explain the difference between this and not having parentheses when you can just go add 3 comma D1 comma D2? I'm assuming it's
that's when we're calling it. You're allowed to, like if I'm going to call this function, let's revise this so that it takes int x, comma, int y, comma, int z. And so our parameter here, I'm going to write a note. I'm going to scrap this one. And we could even do it inside C++. It would not be a bad idea to do so. So I'm going to get Visual Studio going. And I'm sorry to stretch this out. You were probably hoping for the 7-second answer. All right. We're on lecture UVW. That's incredible. By the end of the semester, we're going to have gotten to Y. Too bad we didn't get to Z. We could have felt real proud of that. So new project. Lecture W. Now I'm going to need my boilerplate. I went to a Scottish festival last weekend, and so I must be envious of the people with the cool Scottish accents because I just said something dumb. All right, let's go and actually find my boilerplate, which is on the desktop. Select everything, copy it. I don't see my Solution Explorer, so view Solution Explorer, right-click Source Files, Add, New Item, Lecture W, .cpp, paste. All right, so I'm going to write a function. It was called add3. It takes 3 doubles and returns a double. So double, add3.
Not inside that in there, or
I am so sorry, pardon me.
you're outside it?
I'm trying to mimic this one.
Oh, okay.
Okay, so double add3 and it accepts 3 values, double D1, comma, double D2, comma, double D3. Now that's enough for the prototype. I could just paste this, put it up here above main, and then call it, but it's not going to work because we don't actually have a body. But I could do double result equals add3 10, comma, 20, comma, 30. And it will compile. If there was a compile option here that compiled just this file, yeah, there is right here. It warns me though, hey, function definition for add3 not found. But it built it. It just can't run because there's no body for that definition. It says unresolved external. And then it gives us a whole bunch of gobbledygook. Double space C decal space add3 double double double. So we do need to create a function that matches those specs. I'm not going to type in that header again if I could just copy it, but I better remove the semicolon after I paste it, or else you're going to get a syntax error. And what does add3 need to do? It just needs to create a variable to hold d1 plus d2 plus d3 and then return it. So double R equals d1 plus d2 plus d3, return R. I don't know why I made it R1. Double R equals d1 plus d2 plus d3, return R. And I should print it out, right? So instead of cout hello world, I'm just going to print out result. And it ought to say 60. Yeah, it did. And I should have put an ENDL. All right, so if you're in the back of the room and my monitor is hiding it, this is the add3 function right there. The prototype goes above main, and it's just a function header without any of this stuff. Excuse me, without the body, so it's just a function header ended terminated by a semicolon. And then here's main that uses it. Okay, so Hunter, was your question, could I not do double D1, comma D2, comma D3, or was it another question?
What's the difference between just doing double add3, comma D1, comma D2, comma D3 versus?
You wish that it worked that way, and it's just because that's how they made C++. And I can't give you a good reason why they didn't support that.
No, I mean, like, actually removing the double, removing the parentheses, from the double, just saying double add3, D1, D2, D3. Like, no doubles, parentheses, no parentheses.
Modify your code the way you're suggesting.
Yeah, let me turn. I'm just doing what the difference is between that.
Oh, okay. Excellent question. Excellent question. Why do we have all that when we could do this? And the answer is that this does not define a function. It defines variables. So we have an add3 variable, and we've got 3 other variables. These are global variables, by the way, because they're located outside of any function. But it's not a function. And what a function is it's a chunk of code that has a name. And so since I have a function here, it's a chunk of code that has a name that accepts data values as its parameters and it returns a value. If I tried to list it like that, that's not a proper prototype. It's just a list of variables. That kind of makes sense? All right. Very good question. And something that the book will show, which I don't really agree with, is leaving off the variable names in the prototype. And you can do that. You can take the variable names out of the prototype. Now for me, variable names, parameter names, because those are parameter variables, are useful information. Why? What if we had something like this? And it said, you know, void save patient info. And it had a string, and it had another string. Yeah. How am I supposed to know what goes into those strings? I could scroll down and find the function itself. I could read the documentation. But if I had just put, you know, string name and comma, string address, I know a lot more about what that function is going to do. So variable names are useful information that I don't see a reason to leave out of your prototype. But strictly speaking, you can leave those variable names out of the prototype. There's nothing wrong with doing it like this, or doing the add3 the way that I did it. Because all the compiler needs to know is I'm writing something that accepts 3 numbers, 3 doubles as arguments, and so it's going to have 3 parameters, and that it returns a double. That's all the compiler needs to know about it. But humans, we like extra information. We like knowing what the variable names are. At least I do, right? So I could go back and I could add D1, D2, and D3 there. You'll see examples in the book where they don't. All right, so true, false. Every function must have a return type, even if it doesn't return a value. And that's true in this language. In Python, you don't declare return types. You just define a function. And if you feel like returning something, great. And if you don't feel like returning something, great. But every function in C++ or Java or a whole bunch of other languages does have to have a return type. That's why we have the word double in front of our function. If the thing is going to return a value, if it's going to have the return keyword in it, it has to have a return type that matches. That's okay to kind of return the wrong data as long as it can be converted. If I returned an int, it'd be happy to convert it to a double on the way out the door. But if it doesn't need to return anything, you declare it as void. Like if we write a function called say hello, and it says howdy \n. This guy doesn't do anything that we need to know about later, right? We're just telling it to say hello. There's no return statement in it, so we are declaring it as void. Void means it doesn't return anything. If you took fundamentals, the book talks about having a fruitful function and a void function. That's or a fruitful module and a void module. I forget the terminology in that textbook. It's module, I'm pretty sure. Well, here's a fruitful one because it does return something. And here's a void one because it doesn't. So every function must have a return type. If the function is not going to return anything, declare it as void. Alrighty. Well, guess what the next question is? Tell me if it's true or false. The return type for a function that doesn't return any value is null. Now, honestly, that sounds true. If I was taking this quiz off the top of my head without having seen it, I mean, I wrote it, I would probably check true. The reason I would probably check true is you Python programmers may know that if a function doesn't return anything, it actually does return a special value of none. So if you write a function like this in Python, and all it does is nothing, right? It doesn't do anything. It just has a return statement. And then if you did x is equal to a, and you printed out x, it would say none. But C++ doesn't do that. If it doesn't return anything, it really means, okay, what am I talking about? The return type for a function that doesn't return any value is not null. I just said what it was. It's void. Where'd my source code go? Right. So that is a false answer. It's tempting to say true because we've seen the word null in here, and there. Null meaning empty, right? Void meaning empty. Void. We declare it as void. So that's a big false. Oh, and look at that. Questions 4 and 5 are identical. Tricky. Describe briefly what a prototype is and why you would use one. I should make y'all do that. I've already stated it. A prototype is a definition of a function that includes its name, its return type, and its parameter list. And you can have an empty parameter list, right? Nothing between the parentheses. But no body. Why would you use one? I've kind of explained it, but somebody take a shot at explaining back to me. Simon, why would I use a prototype? Exactly. It's so that we don't have to worry about the order in which the functions are declared. We could put the function below the main or in another file. So the prototype allows us to put the function itself in another file or below where it is called. The book may have a slightly different explanation, of course, but mine's better. No, I'm kidding. Right, but that's the gist of it. All righty. The next one, true or false? Now I'm kind of in a rut. A lot of my true false questions, more often than not, the answer is true just because I hate writing false statements. But if it's a whole bunch of check boxes, right, and you have to click the true ones, then of course there's going to be some false ones as well. So this is true, but why? True or false? Prototypes should be placed near the top of the program or in a header file. Well, what use are they if we stick them at the bottom of the file? That's like just declaring a whole bunch of variables at the bottom of main. I'm not going to use them. If we stuck the prototypes at the bottom of the file, they're of no use. So prototypes to be of use should be put near the top or in a header file that you include. Match the term with its description. Well, let's lecture about it before we answer the question. You see this variable here, D1, and you see this number here, 10. Those are two completely different things. This is called an argument. When you pass data into a function, you give it arguments. Sounds bad. Don't give me no lip. I don't want to argue with you. We give it arguments, and the arguments fill in the parameter variables, or parameters for short. So the parameters are the things that are defined as part of the function header, and the arguments are what you pass that fill in the parameters. Let's go look at the test question again. So a variable in a function that holds a value passed in by the function call. Is that going to be 1 or 2? Or, well, maybe yours are randomized. Is a variable that holds a value passed into the function, is that an argument or a parameter? That's a parameter, exactly. And then the value passed in is an argument. Now that's true no matter whether the argument, the value that's passed in is another variable or not. I'll go back in and I'll give it an example of that. What if I declare a variable called my age for whatever purpose and I stick 100 in it? And then I pass in my age as an argument. It bugs people at first, some people, that this variable doesn't have the same name as that. But they're completely different things. This is a receptacle for that. This gets a photocopy of the data because it's a pass by copy language unless you do something and declare something as a reference or a pointer. So this does not have to be the same name as this at all. And if you make a change to this, it doesn't touch 100. If we went down here and we said D1 equals 0, then my age after this function call is done is still going to equal 100 because it just gets a copy of it. It doesn't bother people if we pass in data and it doesn't match the name right. But, and I understand, a lot of people want to see that variable name equal that variable name, and they absolutely do not have to. They are two completely different things. This is something that provides a value to be copied into here. Now, Rochelle and I are two different people. We don't have to have the same name just because I'm going to give her a copy of my book. I think we're not the same person. No, we're not. Alrighty. So, match the following parameter types with their description. Alrighty then. We lectured about this for about 10 minutes. Last class period. Who can sum it up into their brain? Which one of these is a pass by pointer? And if you don't even remember what a pointer is, that's okay because we got to talk about it again. It's the second one. If you see an asterisk in its declaration, it's a pointer. You're going, what's a pointer? I've slept since improv. Well, we'll cover it. And then pass by reference. Ampersand. Pass by value. It's just the normal one with no special declarations at all. Java and Python do not support either one of these other things, pass by pointer or pass by reference. A lot of languages don't. All righty, which of the following statements are true? No, more than one is. A function may have only one return statement. I'm going to skip that one. Well, okay, great. This one's just the opposite. A function may have more than one return statement, so don't click both. A function must include a return statement even if it is declared as void. Well, let's go and look at my code. I had something called howdy. It does not have a return. Doesn't need one. Some editors will even give a warning if you put the word return there, which I think is obnoxious because it's a purely acceptable. It's totally acceptable to put the word return there, but it's not necessary. So, in our little quiz here, a function must include a return even if it's void? No, return is optional if it's declared as void. A return statement can be used to pass a value back to the code that calls a function. Well, yeah, that's the entire reason for it. The return statement needs to pass a value back, and then the code's going to use it, like this one, right? He returns R so that we can store it and use it. Otherwise, why bother returning it? It's perfectly legal to call a function and not retrieve its return value. It's like you went to the store and you bought me some milk and I just go thanks and I walk away without taking the milk. It's kind of stupid, but yeah, it can. So that one is definitely true. A return statement can be used to pass a value back to the code that calls the function. It ought to be worded even more emphatically. A return statement is used to pass a value back, or a return statement passes a value back. All right, a function may have only one return statement, and that's absolutely false. We can put 20 return statements in it if it's a long function. But, you know, what if I'm just going to create a silly function down here, void, or no, it needs to be something with, you know, int, silly. And then I could make some kind of condition, ask the user for something, you know, cout, enter a number, and then we could do some dumb stuff like this. CIN into a variable. I think I'm just going to wind up deleting this. We're not going to actually call it, but I guess I'll make it valid code anyways. CIN into x, and then if parentheses x is equal to 1, then for some reason we're going to return 100. If x is equal to 2, we're going to return 1,000, 10,000, whatever. If x is equal to 3, we're going to return 100,000. And if none of those things are true, then we're going to return a -1. Right? We have lots of return statements in there, and it's valid code. It'll compile. Why we're returning 100, 10,000, and 100,000, I don't know, but it's perfectly valid to have
What would
multiple.
you have to write to get -1? Nothing. Then how do you like write nothing? You know what I'm talking
Not yet. I don't know what you mean.
about. So what would you type? Would you just put a space and just click enter to get the -1?
Well, if I wanted to see the -1, I could enter something other than a 1, 2, or 3. I could type in a 4 or a 0 or anything else. Yeah, good question. Good question. And maybe I should have written this as if, else, else. Right? I see exactly why you asked your question. What if I had written it like this? It'd look a little bit better. Else if, and then lastly, else, not else, else return -1. That makes it pretty clear how it's going to work. Being just a little bit too clever by sticking everything on one line and not putting else's.
Sorry.
No. All righty. So a function may have only one return statement? Nope, that's false. A function may have more than one return statement? Another example of that, and I'm not going to actually put it in the code, would be something like this. You know,
That's your boilerplate.
int save to file. We try to open the file, right? OF stream, whatever. Whatever equals open, right, file name. And if that fails, if not whatever, return an error code. Else, do something, right? Keep going. And so we could have a whole bunch of code and have a different return value at the bottom. And then when we call save to file, we could check its return code. And if it returned a -1 or a -2 or a -3, we would know it failed. And if it returned a 0, we would know that it succeeded. That is a common programming motif where you make functions return zeros to indicate no errors, and you make them return other values to make them indicate that it's an error. Now, why wouldn't you do the opposite? Why wouldn't you make 0 an error? Because that only lets you dictate one kind of error, right? You might want to dictate a whole bunch of different kinds of errors. So you make 0 the success. Even though that's kind of backwards from that true-false thing, where a 1 is a true and a 0 is a false. 3 statements are true. Oh, well, look at that bad writing. Non-static local variables only exist. But that almost sounds like Zen or Buddhism or something. I don't even know what that means. And I'm the professor. All right, let's go on to the other ones. I need to modify that question. Static local variables retain their contents between function calls. Well, we haven't even talked about static variables yet, so how can we answer these questions? The scope of a global variable is a portion of the program from the variable definition to the end of the CPP file. Somebody just hazard a guess as to whether that sounds good or not, and it's totally okay when you get it wrong. Does that sound good? What's the scope of a global variable? The scope of the global variable is, in fact, from the point where you define it to the bottom of the file. Like if I put a function, a variable here, int Fred equals -1, I'm not going to be able to access Fred here or access Fred up in main. His scope, the place where he is visible, is from where he is declared all the way to the end of the file. And there's no way to declare a variable prototype. So you just have to have the variable declared above where it's going to be used. Something's nagging at me about that statement, and I can't figure out what. So I'm going to pretend that what I just said is true. The scope of a global variable is a portion from where it's defined to the end of the file. Now, if it was a local variable, that's not true. What is a local variable? It's one that's declared inside a function, like R. What is his scope? His scope is not to the end of the file. It's limited to the close brace, right? We can only get a hold of R from here to here. That's why we're returning it. Otherwise, we wouldn't be able to get a hold of it at all. So a local variable scope is only for the rest of the function, or to the close brace in which it was defined. A local variable is available to every function in the CPP file. Now, I just kind of stated that we're using different terms. Is that true or false? Is a local variable available to every function in the file?
False.
Yeah, that's false. And a local variable is a variable defined outside of the functions.
False.
That's false because it's a global variable if it's outside of the functions. And this is just true. I'm going to say it before we read it. Global variables are automatically initialized to 0 or null, whereas local variables must be initialized by the programmer. For some reason, that's true. I'm not strictly sure why it would be a bad idea for the compiler to go ahead and initialize, local variables, but it doesn't. So that is true. Global variables are initialized to 0 or null, which is the same thing as a 0, or false if it's a Boolean variable. But they're all the same kind of thing. A 0 is a false, is a null. All righty. Static variables retain their contents between function calls, and non-static local variables only exist. I'm going to have to look that one up just so that we can give ourselves the correct answer. I'll look it up in a minute. All righty. We haven't talked about it, so I haven't said whether B is true or false. I'll go ahead and say it's true, though. The word static means something different than it does to the Java programmers. In some ways it means the same thing, but in some ways it means something completely different. Select the most correct statement about this. String name is equal to Bob. Is Bob an array? It sure does look like one, because we said that something between quotes is an array. I'm really not liking this question because I would argue strenuously that it is, and I know that it's probably not. Bob is a global variable. Heck no. Bob is a default value. That is true. Bob is a prototype. No. Say hello would be the prototype if it ended in a semicolon.
Can you quickly remind of what is a default value?
Not something we're expected to know until we've lectured about it. And so, just like static variables, we're going to have to talk about it.
Got it.
Let's do it. Let's talk about it. We have the say hello function right here. I don't know if you typed it in, but what if I decide I want to be able to say hello to somebody? String name. Equals, quote, Fred, end quote. And then our howdy message is going to say cout error error quote howdy end space end quote error error name error error endl. What this means is that if we call it and we don't put anything between the parentheses, the name variable still exists and it gets filled in with Fred. Go ahead and cut that and paste it above main just so we can play with it. And yeah, we could just define a prototype for it, but I want to go ahead and do it this way, please. Just come up there and paste that function above main, and we're going to play with it. Say hello to my little friend. Or say hello with nothing. If we did not have this Fred here, that second one would be a syntax error. Like that. You see a little bit of the error indicator there. Too few arguments in function call. That's because we have a parameter here and we're not passing it a value. We could fix that by passing in a value. We could pass in an empty string or something like that. Or we could put in a default value. Default name equals Fred. So if we do not give it a value, when we invoke it, if we don't provide an argument, what is that statement? If you can't afford a lawyer, one will be, provided for you. Well, if we can't provide an argument, then one will be provided for us.
So is that going to say howdy?
This one's going to say, howdy to my little friend.
Fred.
And then this one is going to say, howdy, Fred. Let's run and prove that.
Right.
All right. Howdy to my little friend and howdy, Fred. Because the first time we did provide an argument that gives this parameter variable a name. The second time we did not provide an argument, and so it accepted the default value, otherwise known as a default parameter. Does that make sense, Hunter? That makes sense. We'll probably hit it again when you get the PowerPoint itself. Tuesday. All right, so let's see if that's true. Bob is a default value. What is sneaky about this is that something declared between quotes and it's a series of letters is actually a character array. So if you answered A, then I should have to give you credit for it. But we all know, just to save time, why don't we go ahead and pick C, or whatever order they're in on yours. Two things I need to fix. Three things. I don't like it saying boxy. I don't like it saying non-static variables locally only exist. And that one. So questions 11, 12, and 1. I can't believe I've had this quiz out for like 8 years and not fixed it.
8 years?
I've been teaching for a long time. 1, 11, and 12. I started off as an adjunct though. I had a real job until I became a professor. Okay, so I was a programmer. I programmed for a company in Stillwater, and then they were bought out by a French company, and I didn't want to move to France.
Why not?
To be near my parents. Isn't that the stupidest reason? No, I'm kidding. I should have taken them up on it. I should have gone to France. And so then I went to Enid, and then they were bought out by another company, and I didn't feel like moving to Wisconsin. We just had a kid. We just had a kid. We didn't feel like uprooting ourselves. And so we stayed in Enid, and then finally we decided to move to Midwest City, and I decided I'd rather be a teacher. I like teaching. It's my calling. Okay, so what is a static variable? And since this is true, that one has to be false, no matter what gobbledygook it is, because it says 3 statements are true. So what is a static variable? Well, let's find a non-static variable. Let's make up a non-static variable. We have this method here called say hello. Let's make a new one. Just call it test. Make it really vague. And we're going to declare a variable called x and set it equal to 0. And then we're going to add 1 to x plus plus. And then we're going to see out a message that says in test x equals, end quote, arrow, arrow, x, arrow, arrow, e, and dl. Now in main, let's call test like 3 or 4 times. Test, test, test. Oh, and I also worked for the state for a while, and I should have stayed there because that's job security forever, even though you don't get paid anything. Nah. Alrighty. So, what is it going to print? It's just going to print 111. 111. And how I got my start is I was hired as in an IT department to do maintenance programming and customer support. That's a very common thing, common first programming job. Pardon me? So I run it. 111. Why is it 1? Because this variable keeps getting reset to 0. Every time we call test, it gets reset to 0. And you think to yourself, okay, well, what if I didn't give it a value? Ain't no way that's going to get reset. Instead, it just doesn't work. You have to initialize a variable before you can use it, unless it was declared as a global variable. We could conceivably move this out, make it a global variable, and then everything would work a little bit differently. Like I could cut this, paste it, make it a global variable. I might give it an initial value. Otherwise, it would default to 0. Global variables automatically default to 0. And now when I run it, it says 1, 2, 3. Why? Because nothing is resetting it back to 0. And maybe that's a real good thing. Probably is a real good thing. Otherwise, why would you be making it a global? But the problem with making it a global is any function can get a hold of it. Right? Main could get a hold of it. Down here, I could change the value of x. I can say x is equal to 20. And then when I ran it, it's going to print out 1, 2, 21. Now maybe that's what I want. Maybe I want the ability to secretly go in and change the value out from under the feet of this function. Since it's a global variable, that's kind of what is implied.
Perfect.
Uh-huh.
So how would you allow it not to reset every time?
That's what we're leading up to. And the answer is a static keyword. So we have the ability to make it a global variable. That is one way to solve the problem. The other is to move it back in here, but call it static. And by the way, since it's now defined in that function, I can't get a hold of it here anymore because it's local to that function. So this line is an error. I have to delete that x is equal to 20. So that data is safe. Nobody else can get to it to change it. It's this function's property. So it's safe and sound, and it does not get reset to 0. 1, 2, 3. So that's what the static keyword does. Is it defines a variable that does not reset each time. It does not lose its value when the function exits. In effect, it is a global variable that's only accessible inside that function. It is stored outside of the function. It's stored in the same place that global variables are stored. It's just that you can't get a hold of them. And you Java programmers are going, well, that's a different usage of the term static than what we used it for in our class, and that's true.
So why not use const instead of static?
Const means it can't change. Right, if we make that const, then this is a syntax error. Const means, oh, once you have a value, you better not change, which is kind of like the complete opposite. Yeah. You make a static variable so it can change.
So it can change.
But maintain its value. Okay, so non-static local variables only exist. Don't choose that one wherever it is. Static variables retain their contents between function calls, or they are not erased when the function leaves, exits. That's a way to say it. A local variable is available to every function in a CPP file. Not true. A local variable is any variable defined outside all the functions. That's not true. That's a global variable, and global variables are automatically initialized to 0 if no initial value is provided. So those are our true ones. I hoped I earned 100 on my quiz. I'm seeing lots of 0 points here. I failed my quiz. No, I'm kidding. But I made an 85. Did anybody score above an 85? Is the preview function wigging out on me, or did everybody get an 85?
Wait, is the one with void wrong on your screen?
Yeah. Okay, this one had to be graded by hand, so I'm not surprised that that one gave me a 0. Every function must have a return type. Yep, that's true. I got my point there. True or false, the return type for a function that doesn't return any value is null. That's false. The return type for a function that doesn't return, okay, I thought it was a duplicate question.
No.
It's not a duplicate question, and I should have chose true. I'm sorry I didn't catch that before everybody submitted it. And then this one had to be graded by hand as well.
So you'll grade zeros by hand?
I'll go in and I'll give everybody 100, because I told you this is false because I said it was, you know, a duplicate question, but it's not, because that's definitely a true statement. It's a good idea to take the exam a second time, the quiz a second time, right? Good prep.
It doesn't really tell you what you got, though.
Well, when I scroll down to the bottom, it did, but that's because I'm a professor. Yours hasn't been graded yet, so it doesn't tell you. Is that true? If it was all true, false, and multiple choice, it could tell you. But since I haven't graded, the pieces have to be graded by hand, it won't tell you. But I'll do that tonight so you can eyeball it. Why don't we go and look at the Chapter 7 quiz? We have lectured a lot over chapter 7. Let's see if we know enough to feel comfy about it. Y'all like this, right? You like going over the quizzes like this?
Yep.
I hope so.
And not because of the grade, but because we understand it better.
Yeah, we get to talk about it a lot.
Yeah.
That's why I like it. And I know secretly it's because you like the grade. No, I'm kidding. I'm teasing. I'm teasing.
I mean, it doesn't hurt.
Doesn't hurt. All righty. So, which of the following statements are true? Now, I'm expecting y'all to be able to answer these questions for me. If I see something that I don't think we've covered, or that you see something you don't think we've covered, that's fine. But is an array a variable that can hold multiple values of the same type?
Yeah.
Does that sound good? Wave your hand if you agree with her, Shelley, because she's correct. All right. If you declare an array of ints, you can also store strings in there. And that sounds kind of hinky. And no, once you declare an array as an array of ints, that's all you can put in it. Or some data that's compatible with ints. Once you allocate an array, its size will grow and shrink as you add data to it. Nope, that's a Python list or a C++ vector or a Java array list. So that's false. Don't be fooled by the fact that I clicked it. It's false. Yours are probably in random order, right?
Yeah.
All right. Values of an array in C++ are stored in adjacent memory locations.
Yeah.
That's absolutely true. That's why they're awesome. They're awesomely fast because they're all just right there in a row. And arrays are declared using square braces. I could have been mean and said that they are declared using, something else like curly braces. And then maybe you would have looked at it and thought they were square braces, but I wasn't trying to be a jerk. Now, it's interesting that I made something with 4 true statements and only 1 false. Usually I try to balance it a little more than that. All righty. We've done this. I want somebody to tell me how to do this.
Int.
Yeah, write a line of code that declares an array of type int. Well, that's a good hint.
What's the difference between that and constant? I keep getting that mixed up.
Const means it can't change. Right, so you create const name equals Fred. Well, it's never going to change. I can't fill it in. I can't let the user type in anything else. Does that make sense? Yeah, that's what const does. And so, what's the name of the array? Tests. It should be 5 elements long. Square brackets 5. And don't use an initialization list. Don't forget the semicolon. If you forget the semicolon, it counts you wrong and I have to go back and give you the point. If I was a jerk, I'd count you wrong for leaving the semicolon, but I'm not. Well, I mean, I may be a jerk, but not for that reason. Write a line of code that will declare an array of type string. All right, the array should be called colors and use an initializer list. And oh, by the way, don't specify the length of the array, let the initializer handle it. All righty, so somebody tell me what to do here.
String colors.
Yep, string, space colors. Now I forgot something maybe. I need something that's going to tell me that it's an array. Because right now it just looks like a string, like I could do that. It's not an array, it's a variable. I need to mark it as being an array. How do I do that? I put square braces. Right. Equals, and now I put my initializer list, and I was so kind that I even gave you the syntax for it. Curly braces, double quotes, and all that, so you could just copy and paste that.
Oh, I'm ready. Why not?
There we go. True or false? This code will initialize every element in scores array to 0.0. Now, I've talked about using an initializer and putting only one value in it. If I put one value in the initializer list, what it does is it sets the first value in the array, the first element in the array to that value, and then it leaves the rest of them 0. So does this sound good as a true or false question?
Because the rest is going to be 0 without the point 0 at the end.
Okay, I could start to argue that it's false because it's going to initialize the first element to 0.0 and then it's going to initialize the rest of them just to 0. but for a double, they're the same thing. So I would say that's a true statement, and if somebody wants to tell me why it's not true, I'm certainly pleased to repeat why. I mean, is that an okay answer? Do we agree now that I've stated it that way, or who said it was false? Yeah, so how come? Okay, you understand? Okay, so yeah, it's definitely a true statement. This is how you initialize everything in an array to 0.
Is this purely for double or?
No, for int, floats, longs, whatever. And really what it is that it's setting the first value equal to 0.0, and then it's setting the rest of them to 0. If our syntax looked like this, remind me not to save all these changes in my boilerplate. If I did something like this, int x 100 equals 1 comma 56 comma 98, like that, then what happens is x subscript 0 is equal to 1, x subscript 1 is equal to 56, x subscript 2 is equal to 98, and then all the rest of them are set to 0. x3 through, what's the last element we can access here? 99 is the last element. So x3 through x subscript 99 are all left 0 because they were not given any values in this initializer list.
Can I just write that? Okay.
All right, which of the following statements would print the first element? Scores 1, scores 10, scores 0, or scores 9 if the array is declared. Well, it doesn't matter how it's declared. The first element is going to be which one? Say it out loud. Bold. Outside voice.
0.
0. All right. Which of the following statements would print the last element? Well, if it's linked 10, that means the last element's going to be 9. What would be a good way to calculate the number of elements in an array of ints called scores? These may be randomized for you. Size of scores divided by size of int. Whoops, that's a multiply. I'm not digging the multiplication there. I think the way to calculate the number of elements is to take the size of the array, dividing it by the size of the elements. So asterisk looks like a wrong thing. How about size of scores divided by size of int? Does that seem like a good way to calculate it? Since it is an array of ints, yeah, that'll do it. How about size of int divided by size of scores? Well, that's like trying to calculate your average by saying I have 3 scores and each one was 100, so I'm going to divide 3 by 100. That's not my average, right? It's 100 divided by 3. You want the big number divided by the little number. The big number is going to be the size of the array, and the little number is going to be the size of the element. So that's not right. Those are swapped. And how about size of int times size of scores? Okay, the fact that it's multiple choice kind of indicates that it's wrong, but why is that one wrong? It's multiplication, and you do division to calculate the size. Right, if you had a train and you knew that 100 people were in the train and you knew that each train car held 4 people, nah, that's silly. Each train car held 25 people, how would you figure out how many cars were in the train? 100 people divided by 25 people. Same with arrays. The array is 100 bytes long, and you know that it's containing ints. Well, 100 divided by the size of an int is how many ints there are. And who remembers how many bytes are in an int? Yeah, 4. Alrighty, so if you have this array, what's a good way to print it? You know what, this kind of thing is almost worse than just asking somebody to write the code to print it, because your eyes start to cross. And they're probably in random order. But somebody staring at this, if I can zoom in, tell me if this will print out the array. For integer x, colon IA, print x. Are you feeling good about that one? Yeah, for each x in the array, print x. That is correct. That is a good one. So somebody, okay. I'm going to skip this one, and I'm going to come to this one. I'm going to look at D now on my list, not yours. For I equals 0, I less than num, I plus plus, print I. What is that going to print? Does it even have any mention of the array?
0 to 9, but also it says I less than. So I'm not sure if that's valid code.
Yeah, that's completely valid. It's completely invalid. As a matter of fact, all of these with the less than should not be counted as correct. Guess what? Professor has to fix that. All right, we're going to pretend that those are single equal signs. But this one's not valid because if it was not a syntax error, it would print 0 through 9. How about this one? I equals 0, I is less than num, I plus plus, print out IA. That's just going to print out, yeah, it's just going to print out the memory address of IA. This language would not automatically convert it to the contents, unlike some other kinder languages. So that one's not good. You don't want to just print out IA. Instead, you want to print out IA subscript I. Now that's nice because we have an index counter going from 0 to 9. Print out array element I. That's perfectly good. Other than that, less than. And this last one. This has got the same problem that the one above it has. For every integer x in IA, print out IA. Nah, what do we want to print out? How would we fix statement F? Yeah, just delete the IA and replace it with an X. Right? If that was gone and it was X, it would be a good loop. Because that's what this means. For every X inside IA, for every integer inside IA, print that integer out, stored in X. So that's bad. Now, I skipped this one. We're going to go way back to it now. I mentioned this on Tuesday as being the wrong way to print out an array. What's wrong with this one? IAX, IA subscript X. That looks like a good way of accessing an array, right? But it's not. And why is that? Because this is a for each loop. Who knows what numbers are stored in the array? It could be 10,000, comma, 10,001, comma, 10,002. And in that case, is IA subscript 10,000 going to be a good idea? If the array is only 10 elements long, then printing out IA subscript 10,000 would be a very bad thing. So if you're going to use the for each syntax, you just print out the variable itself. If you're going to be using an index-based loop, go ahead and use the variable followed by the subscript. That makes sense? Somebody give me some bold, assertive thumbs up, or do we need to lecture about that? Which is okay, I'm happy to talk. I see one thumbs up from somebody in the advanced Java class, so I want to see some other thumbs up. You good? You good? Ever alrighty. Parallel arrays. Did we not talk about parallel arrays? I'm pretty sure I have said that what is a parallel array? It's two arrays of the same length. Does that sound familiar? Mm-hmm. Okay, so parallel arrays should be of different lengths. No, arrays are of the same length. Why don't we just give the definition and then work backward to answer the true-false questions? Parallel arrays are two or more arrays of the same length that hold related data or hold data where the elements are linked by their index numbers or by their subscripts, where the elements are related by their subscripts. So we have string names equals Joe, end quote, comma, quote, Bob, end quote, comma, Sam, end quote. And then we have int ages equals 12, comma, 14, 15, comma, 13. So what index number is Joe?
Well,
Not his age, but yeah. Yeah. So what's his index number? What's his subscript?
oh, 0.
0. And so the ages subscript is 12. So Joe is 12. Bob and 15 are both at index 1. So the elements are related by their subscripts. They're linked by their subscripts. Conceptually linked by their subscripts. So parallel arrays should not be of different lengths. Are parallel arrays two or more arrays that contain related data?
Yes.
Yeah. How about parallel arrays may be of different types? Well, if we just look at my example, are these of the same type?
No.
No, they could have been if, like, they were first name and last name, but they weren't. They don't have to be. And to use parallel arrays, elements of the same subscript are related. And yeah, that's true. If it is unknown how much data an array will be holding, you may winding up using a partially filled array. I mentioned partially filled arrays. Okay, so this is just flat out a true statement. This is not true false. If you don't know how much data is in the array, it can be a partially filled array. You have an array called scores. You don't know whether there's 0 scores in it or 100 or somewhere in between. So if we have a partially filled array, it's implying that maybe there's some data in it, but it may not be full. So which is true? Should we make the array large enough to hold the largest expected number of elements? Yeah, if there's going to be 10 homework scores for the semester, I better not make the array only 5. So I don't know if this is randomly sorted for you, but that's definitely a true statement. The array should be large enough to hold the largest expected number. Now you can get overzealous. If I'm trying to keep track of the number of students who are going to rows, I don't need to declare the array to be 10 million elements long. We don't have quite that many students. Using a counter variable to keep track of the number of items stored in the array. Oh, well, that gives it away. Yes, you use a counter, right? And the counter says, oh, there's no data in the array, or there's 10 items in the array, or there's 100. And then when you process the array, you should go from the beginning to the end, ignoring the counter variable. That's not true. All righty, we don't have enough time to answer all these questions, so I guess I'm going to give you the answers, or we could just leave the quiz unsubmitted. But why don't I give you the answers, and then we will lecture about why they are true next time. So a nested loop is not a valid way to access the data in a two-dimensional array. Well, we didn't get far enough into the chapter to know what a 2D array is. But a nested loop is absolutely how you do it. There's really no other way. So that's not true. A two-dimensional array declared as 4 by 3 will have 7 elements. No, if you have an Excel spreadsheet that's 4 by 3, how many elements are in it? 12. You multiply them. A loop is a good way to compare two arrays. Yeah, that's true. To compare two arrays, you must compare the arrays element by element. And yeah, that's true, right? If you have two lists and you want to see, whether both lists contain the same names, you have to look at one, you have to look at the other, and you have to, be looking at each one. So you have to compare element by element. And in a two-dimensional array, 4 by 3 will have 12. All right, so again, we had too many true answers. More than one being true, oh boy howdy, 4 of them were true. All right, and then lastly, is this an example of a range-based for loop? Somebody tell me if this is a range-based for loop, which we were also calling a for each. That's definitely true. If it was for int I equals 0, I less than blah, 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 it would be an index-based for loop. Alrighty, so I'm going to have to go back and lecture about those three, but we were running out of question. Ooh, look at this. It's saying I got something wrong. An array is a variable that can hold multiple values of the same type. But that can't be wrong. If you declare an array of ints, you can store strings in it. Oh, I checked that and it's not true. I hope you didn't check that. I said it wasn't true, and then apparently I clicked it anyways. You may have to take the quiz again if you're not getting all these right, which you can't tell. Right? Like I said, I'll go through them, I'll grade them tonight, and then you can eyeball them. Once you allocate an array, okay, that has to be the one that's wrong. We got that one right. Write a line of code that has to be graded by hand. We got that one right. We got that one right. Didn't get that one right. Didn't get that one right. Got that one right. Ooh. Professor failed the exam here. You got another one wrong.
I don't think I saw you clicking all of them, to be honest.
I did not select all of these.
No, you didn't.
All right. It's flaking out. All right. Yeah, and I know I did not select 7.
Yeah.
All right, so, okay. All right. Definitely take it again, especially after we lecture about the last few questions on Tuesday. So what are we going to do next? We're going to lecture more about functions. I think we're pretty good on the functions. There was only a couple of topics that we didn't know, but we have to, brush up on them, finish that one, and then we need to finish Chapter 7, which is not going to take like more than 10 minutes to cover that topic. It's just that we've run out of time, and I don't want to keep y'all past 11:22. All right, we didn't have a homework. Excuse me, we didn't have a lecture to upload, so we're good there. I don't think it's appropriate to assign a homework assignment just after doing a whole bunch of quizzes, so I think we're done. I don't see anything we need to upload.
No. The lecture W.
Oh, did y'all type in notes?
Yeah.
Okay, well, we can make a Dropbox, but if you don't upload anything into it, I'm not going to count off because not everybody took notes. Oh, you're right. We typed in Visual Studio Notes. What am I flaking out on? All righty. All right, there's a Dropbox there. W. All right, I don't have to leave immediately, so if you have questions over homework and stuff. And by the way, it was pointed out to me that you could not get a hold of the assignment for that the attachment wasn't visible. You'd click on it and get an error message. And that's really irksome because if you went to content, you can open it there, but not everybody goes and looks at the content homework page. So I think it was a simple arrays assignment. I'm extending the due date on it since people couldn't open the attachment if they didn't go to, unless they went to the content page. But we got a lot of submissions for it. Thank y'all. All right. Sure, nobody wants to stay and play with homework?
I've got one.
I'm sad. Yay! All right.